What does it really mean for an AI to think? Today, we're diving deep into microservices architecture, velocity at scale. Digital leadership hinges on deployment frequency and change responsiveness. Microservices architecture decouples development, deployment, and scaling. Independent services owned by small teams enable parallel innovation. Cloud-native ecosystems demand this modularity. It is the architectural substrate for modern SaaS. Strategic advantage accrues to those who decompose early. The architecture is built on three pillars: business-aligned boundaries, infrastructure automation, and decentralized governance. Microservices are not merely a technical choice, they rewire organizational velocity. This architectural style shifts the organization from project-based releases to continuous value streams. But here's where it gets interesting: the monolithic bottleneck. Monolithic applications couple deployment, scaling, and failure domains. A single codebase forces coordinated release cycles across features. Scaling requires replicating the entire monolith, wasting resources. One memory leak can take down the whole system. Innovation slows under increasing coordination cost. The monolithic model is optimized for simplicity at the expense of agility. As team size grows, cognitive load exceeds manageable limits. This structural ceiling is not solved by better engineering. It is an architectural constraint. The result: velocity plateaus while complexity grows. The monolith becomes the bottleneck. Visual monolith diagram: one large block, all components interwoven with release train queue. So what's the real problem? Let's talk about root cause: entanglement. Tight coupling arises from shared data models and in-process communication. The monolith violates the bounded context principle: multiple domains fused into one schema. Changes in one area ripple unpredictably. The database becomes an integration monolith, creating a shared schema liability. This entanglement resists modular thinking. Organizational scaling compounds the issue. Conway's law ensures the system mirrors communication chaos. The root cause is the absence of domain boundaries. Without boundaries, complexity grows exponentially. Change becomes high risk and slow. Visual: spaghetti architecture, tangled lines connecting modules, and a giant shared database. This raises a critical question: breakthrough, decompose by capability. Microservices decompose systems by business capability. Each service owns its domain logic and data. Bounded contexts define clear boundaries, informed by domain-driven design. Teams become autonomous, reducing communication overhead. Deployment independence eliminates synchronized releases. Scaling is granular-only: bottleneck services scale. The architecture replaces internal method calls with API contracts. This is the fundamental breakthrough: modularity at the system level. It enables technology diversity and independent evolution. The trade-off is distributed system complexity, managed by infrastructure. Visual: monolith cracked open into bounded context, each with its own data store. Now, let's zoom in on the microservices system. A microservices system is a distributed set of self-contained services communicating over a network. Each service is a deployable unit, typically containerized. An API gateway routes external traffic, enforcing security and rate limiting. A service mesh manages internal east-west traffic, providing mutual TLS, observability, and resilience. Event buses enable asynchronous integration. Orchestration platforms like Kubernetes handle scheduling and scaling. Observability spans logging, tracing, and metrics. This layered model is the operating system for cloud-native applications. Here's something most people overlook: component architecture. Key components form a layered runtime at the edge. An API gateway handles ingress routing, authentication, and rate limiting. Internally, a service mesh provides mutual TLS, traffic shifting, and circuit breaking. Asynchronous communication relies on an event broker for pub-sub-pub and event sourcing. Container orchestration, Kubernetes manages the deployment and scaling. Each service has independent CI/CD pipelines and its own data store. Observability stack aggregates logs, metrics, and traces. Configuration is externalized. Secrets are injected at runtime. These components form a cohesive, resilient application fabric. Visual, exploded component view gateway, mesh sidecars, broker, Kubernetes nodes, CI/CD pipeline icons. Think about this for a second. Delivery workflow. A developer pushes code. The CI pipeline builds, tests, and packages a container. The container is pushed to a registry. CD deploys to a staging environment, running smoke tests. A canary deployment routes a small percentage of traffic to the new version. Service mesh enables gradual, weighted traffic shifting. Telemetry flows to dashboards. Anomaly detection triggers automatic rollback. After validation, full promotion. This pipeline operates independently per service, enabling multiple deployments per day. Visual, workflow pipeline, commit, build, test, canary, observe, promote, with traffic splitting. And this is where things get complex. Impact, accelerated delivery. Metrics, deployment frequency increases from monthly to daily or more. Lead time for changes drops from weeks to hours. Mean time to recovery MTTR falls from days to minutes. Change failure rate decreases. Teams achieve true end-to-end ownership. Scaling becomes cost-efficient and precise. Innovation velocity unblocks product differentiation. The business shifts from project-based releases to continuous value streams. This is not just a technical metric improvement. It is a fundamental business acceleration. Microservices make this possible. But here's where it gets interesting. Resilience by design. Microservices enforce fault isolation. One service failure cannot cascade. Circuit breakers monitor dependencies and trip to halt cascading failures. Bulkheads partition critical resources to limit blast radius. Retries with exponential backoff and jitter handle transient faults. Health checks enable automatic container restarts. Chaos engineering proactively tests resilience. The system degrades gracefully, preserving core functions. Resilience is not bolted on, it is architected into the mesh. Observability provides real-time health visibility. This structural resilience reduces downtime and customer impact. Visual, service mesh with circuit breaker icons, bulkhead partitions, retry loops, and chaos monkey. So what's the real problem? Let's talk about data sovereignty. Each microservice owns its data store, ensuring encapsulation. Polyglot persistence allows choosing the right database per service. Document graph, relational key value. Event sourcing captures state changes as an immutable log. CQRS separates read and write models for performance. Data consistency is eventual. Sagas coordinate transactions across services. This decentralization is the most challenging aspect, requiring patterns like outbox and change data capture. The benefit: no shared schema bottleneck. Data autonomy eliminates the monolithic data model. This raises a critical question: future trajectory. Serverless functions reduce operational burden for ephemeral workloads. AI-driven orchestration predicts scaling needs and optimizes resource allocation. Service mesh extends to edge locations, bringing microservices patterns to IoT and CDN. WebAssembly emerges as a lightweight, portable runtime for polyglot microservices. The ecosystem moves toward autonomous self-healing and self-optimization. Multi-cloud portability becomes a key design principle. These trends will further abstract infrastructure, allowing developers to focus on business logic. Future is adaptive, intelligent infrastructure. Now let's zoom in on adoption strategy. Begin by identifying bounded context within existing systems. Extract services incrementally, prioritizing high change areas. Invest in a robust platform, CI/CD, orchestration, observability, mesh. Focus on team autonomy and clear API contracts. Measure success by deployment frequency and MTTR, not just uptime. Microservices adoption is a socio-technical transformation. It requires organizational alignment. The journey is continuous. The architecture evolves. Start with a monolith if managed. Decompose when friction exceeds benefits, no one size fits all.